All right, so let's come back to the motion, to the circular motion. Look, what's the difference between studying a curve by thinking of a particle moving versus studying a curve by looking at the shape? Well, the difference is that a particle moving along the curve can be moving quickly or slowly. Now, if a particle moves quickly and follows this curve very quickly within speed limit, 70 miles per hour, okay, but making that curve, would you experience large acceleration here, pushing you to the side? Well, essentially, that's all you experience sitting in the car if you are asleep, if someone else is driving. Right? So imagine you are driving, well, someone else is driving you, and you are falling asleep. What is it that you feel about the motion? You only feel acceleration. If the car is moving straight with the same speed, you will not experience anything. You will sleep peacefully for the whole trip, not being bothered. But, well, you know, the driver wants to make turns. The driver also wants to accelerate and slow down. And that's what you will feel. Now, acceleration and slowing down is about driver pushing the gas pedal or brake pedal, right? And it's not about the property of the road that turns left or right. So that's why this tangential acceleration, the acceleration along the road, has nothing to do with turns left or right. So physics says you feel it for a different reason, not because of the road. And the road makes the driver turn, and that makes car push you, right, left or right. But if you follow this road with the speed 70 miles per hour, you will experience a hard push, right, just to keep track of the road. What if you drive slowly, like 45? You cannot go below 45 on interstate, right? So you drive slowly. Will you experience the same acceleration at that point? No. Will it be more or less?
Less.
It will be less. So the acceleration itself depends not on the road. It also depends on how quickly you follow the road. So this concept of normal acceleration, it carries more information than just curvature of the road. It carries something about the speed. And what we want is to subtract that speed influence from that concept. So you said the quicker I go, the more that acceleration is. So is it proportional to the speed? Because if it is, then I can divide by the speed, make this new concept, orthogonal component of acceleration with respect to velocity. Well, it's magnitude, right? I would divide it by the speed. And that would be hopefully something that depends only on the road, not on the speed anymore. So here's the question. Is it proportional to the speed? What is it proportional to?
Speed squared.
Why? Why not speed cubed?
Because formula is A equals V.
Well, because that hints us, right? That formula tells us that if you divide acceleration by the speed squared, in this example of circular motion, you get something that is totally independent of the speed. Independent of anything about the motion but the radius of the circle, the geometry of the road. So what we expect from that formula is that the orthogonal component is proportional to the square. So we divide by the square, and we hope that that is a property of the road. called curvature. But the problem is that our guess is based on a very, very simple motion. When the motion was constant speed, constant acceleration, only changing direction. And that was very essential for derivation of the formula. Right? That was essential to have everything changing very smoothly and to have similarity of these two pictures. If we don't have similarity, we don't have those ratios. So that formula gives us only a hint. And now the real job is to check whether this is true in any motion. Whatever motion is, you compute that magnitude, divide by the speed squared, and that is something about the rho. And what should that hopefully be? Well, it should be 1 over the radius. So what kind of radius? Well, the radius of that circle. So, there's going to be a video of me talking about that formula and explaining that formula. Maybe 50 or 46 minutes long video on YouTube. I will send you a link later, and I will ask you to watch that video, and I will not explain that in class.